Hello, this is question 19 on your June 2022 paper 2 from AQA. You have a rough wooden ramp is 10 meters long and is inclined at an angle of 25 degrees above the horizontal. Bottom of the ramp is O and a crate of mass 20 kilograms rests at the point A. The crate is pulled up the ramp using a rope. Once in motion, the rope remains taut parallel to the line of the tension of the rope is 230. So we know this value of the tension is 230. We know the weight because it's 20 kilograms times G. We will have a normal reaction. And we will have a friction because it says it's rough and it's moving up, so the friction is down. And we have an acceleration that is 1.2. Yeah, find the coefficient of friction between the crate and the ramp. We know if it's moving, friction is going to be maximum, is going to be mu normal reaction. So to find the coefficient of friction, we are going to find the friction and the normal reaction. I'm substitute here. For finding the friction and the normal reaction, we are going to find the components of the weight parallel and perpendicular to the slope. This is 25 and this is the adjacent, so this is going to be 20g cos because it's adjacent, 25, and the opposite one is the sine, so this is 20g sine 25. Yeah, so to find the friction we are going to resolve parallel to the slope. Sorry, to find the normal reaction we are going to resolve perpendicular to the slope. So parallel to the slope, equation of motion, F is mass acceleration, says resultant force when it goes up is the tension minus the pink one minus the friction. So the tension is 230 minus the friction minus the component of the weight. So 20g sine 25 is going to be equal to the mass, which is 20 kilograms, acceleration, which is 1.2. Yeah, and from here we find the friction. So the friction is going to be 230 minus 20g sine 25 minus 20 times 1.2. This is, and be careful because sine alpha must be in degrees, and sometimes we don't notice when we are doing mechanics questions. Oh, I'm keeping the G. Yeah, so be careful with the calculator in the mechanics questions because it's quite common you have it in radians from a pure question. This is 123.166 newtons. And if I resolve perpendicular to the slope to find R, my equation of motion is going to be normal reaction in one direction is equal to the component of the weight in the other one. So R is going to be equal to 20g cos 25, which is 177.636 newtons, which means that mu is friction divided by normal reaction, so it's going to be the 123. Just keep the numbers in the calculator to round at the end, so I just put them in the memory and then I round at the end. This is 0.6933. They don't ask me to round to anything in particular, so I'm going to round to 2 decimal places. I think for the coefficient of friction is perfect. Yeah, 0.69. This is part A. Then for B, it says the crate takes 3.8 seconds to reach the top of the ramp. Find the distance OA. Be careful because the crate is here and they're asking me the distance from O to A. But they give me information between A and the end of the ramp. So I'm going to find this distance and then I have to subtract from 10 because the ramp is 10 meters. Yeah. If they talk about distance, I'm going to use subat because my acceleration is constant. I know it starts from rest and I know the time it takes. So I'm going to use subat equations. So I'm going to write subat. I need the displacement Initial velocity is 0 because it starts from rest. Acceleration is 1.2 and the time is 3.8 seconds. So I'm going to get an equation without v, which is this one. So from the list of Suvat equations, this one has no v. So the displacement that I need is 1/2 times 1.82 times 3.8 squared. This is 8.664 meters, but this is this distance. So from A to the end of the ramp, I need 10 minus that. So the distance that they are asking me, OA, is 10 minus 8.664, which is 1.336 meters. Yeah, and again, you can run, for example, to 1 decimal place. The last thing they ask is, other than air resistance, state one assumption you've made about the crate in answering to part BI. And they don't tell me anywhere. Crate. They don't mention anywhere, but I have assumed that the crate is particle. Yeah, it's a particle, and that's why I can say that it reached the top of the ramp, because I'm considering like a little dot. So I have considered crate is a particle, is modeled as a particle, and they don't tell me it's modeled as particle. And that's all with this question.